In this video, we need to determine when a piece of machinery needs to be replaced. So in this spreadsheet, we've got a bunch of information that would have been drawn from various places within a business. On top, we've got the cost price of the machinery, and then we've got information pertaining to the running costs or the costs and the value of the machine over a number of years. So over here we've got 5 years. So this information for the costs and the resale value all comes into play so that we can calculate the average cost over the age. So our goal is to replace this machine at the point where the average cost is the lowest. The average cost over the age of the machine is the lowest. We want to replace it when that is at a minimum. So in order to do that, we need to do some type of regression. So if we plot the relationship between the average cost over age and we compare that to the age, we will see a specific relationship between the two variables. And based on the nature of that relationship, we need to determine what type of regression is necessary. In this case, we need a quadratic regression in order to determine the minimum age at which our average cost for the machine is at the lowest. So in order to do a regression, I won't go into too much detail. We've got our y variable, which is the average cost, and our x variable, the age. In order to do a quadratic regression in Excel, we need to add another x variable, which is the x variable squared. So that's what we've got here, and then we'll use this information to do the quadratic regression. So once we've got all the information, we can do that. We go to data analysis and regression. So here we've got our y variables, the average cost. My dog seems to want to join the conversation. Let me just close the door. So we've got our y variables, which is the age and the age squared, and we've included our labels. So let's do that. Now with the regression output, we can see that it's quite a good fit. 96, 98, 99. Our f value is larger than our significant f, and our p values are all below alpha, which suggests that the results are significant, and we can go ahead with our calculations. So up top here we'll put in age. That's the age of the machine, and here we'll add the average cost. Our age, let's just remind ourselves, the age is the x variable, average cost is the y variable. And now what we need to do is plot our regression equation. So our average cost equals the intercept plus our x variable plus our x-intercept multiplied by the x variable plus the squared intercept, just squared intercept multiplied by our x squared. So based on the age, we should be able to see what the average cost will be. Now, in order to minimize the cost, we need to use another one of Excel's abilities, which is the solver. And what we need to do here is set the objective of our regression equation. We want to minimize the cost, and we want to minimize the cost by changing the age of the machine. So what this is going to do is it's going to look at the best age or the most appropriate age for minimizing the average cost of the machine based on the quadratic equation that we have calculated. So if we solve this, we see that it's plotted, it's plotted the age at which the average cost is minimized. So we've got let's just copy that over. So let's just do a quick calculation, a check to see if our sums are correct. Let's copy this over as well. So at 3.36 years, this value. So let's change that to 4 years and see how it changes in relationship to the calculated value according to Excel. So there we can see the price went up. So obviously at a later age the price is higher, so Excel has been correct in that direction. And if we go down to 3 years, we can see the price went up as well. So it's likely that this number that Excel has calculated is correct. So very simple, we can just do that again, and Excel calculates at what age our average cost of the machine over the life of the machine is at a minimum. So we can use this then, 3.37, we can say replacement or due for replacement 3.3 years, 3.37. That would mean that after 3 years and 12 months, 3 years and 4 months, sorry, this machine would be, the average cost of this machine would be at a minimum, and that would be the best time for us to replace the machine. So as you can see, this type of analysis is very useful for any business that's trying to minimize costs, and this is a very good way to do so.